What's going on, guys? Hello and welcome. Thank you for joining us tonight. It is Wednesday, June 11th, and I am here to kick off our third Cyber Rush Week presentation as part of the Season 5 US Cyber Open. If you haven't caught one of our earlier sessions, my name is Brad Wolfenden. I'm the Director of Cyber Sports here at Cat's Eye Play Cyber. And before I introduce tonight's guest speaker, just wanted to run through a couple of reminders and updates as we work our way through our Season 5 kickoff series of events. Um, Number one, the CTFs are alive and running. We are nearly at 1,000 unique users with at least one plus solve. So that's been very exciting to see. Really cool monitoring all the Discord chats and seeing all of that come through. So help us get there. Bring some friends, have them get registered, jump in. If you haven't solved a challenge yet, take a look at the rules challenge or the Discord challenge, some of the beginners game room challenges. Those are all available through June 18th, which is exactly 1 week from today. That will come down at 11:59 p.m. Eastern. That is 8:59 p.m. Pacific time on Wednesday, June 18th, for the conclusion of both the beginners game room and the competitive CTF. Kind of on that note, just as a reminder, these competitions are individual competitions. We've been looking into some of the traffic and some of the other data that we're collecting on the back end and looking at some of the capabilities that we've built into the CTF platform to make sure that folks are competing as individuals. So don't think you're slipping anything by us. If you are working with the team, we probably know about it and you will probably be hearing from us. So take another look at some of those rules that have been published both in Discord and then on the CTF platform itself. There's a rules page there, and make sure that you are familiar with what we've set forth in terms of competing fairly. With that, the next couple of reminders that I have are more specific to those of you that are pursuing a spot on the US Cyber Team and or the US Women's Cyber Team. The fact that we are 1 week out from the close of our CTFs means we are also 1 week out from the deadline to submit your application. That is one of the minimum eligibility requirements for both the US Cyber Team and the US Women's Cyber Team. So take a look at that application. If you have not done so already, there are opportunities to submit things like letters of recommendation, GitHub repos, maybe CTF challenges that you've built or write-ups that you've published on CTF challenges that you've solved. So I'm bringing that up to encourage you not to wait to the last minute. I don't want anyone to kind of get to a half an hour before they're due and realize that they could have uploaded a letter of recommendation if you think that would benefit your candidacy. You still have a whole week, and those pieces are not mandatory in terms of submitting a letter of recommendation with your application, for example. They are optional, but just so you don't feel blindsided by any of that, take a peek at that application. It's apply.uscybergames.com is where you will find that. It's a red box right in the middle of the screen. It says US Cyber Team and US Women's Cyber Team application. If you are pursuing a spot on both of those, one application is totally fine. You don't need to submit one indicating US Cyber Team and one indicating US Women's Cyber Team. We will take care of that and make sure that your candidacy is being evaluated for one or both. The last update that I wanted to share is more specifically about some of the prizes and things for the US Cyber Open. I've been getting a lot of questions, a lot of kind of help tickets coming through, asking about the prizes. My recommendation would be to just check out the announcements channel. All of that's been published since we kicked things off last week. You can learn more about heading the winners for both the game room and the competitive CTF right there in the Season 5 announcements channel. All of that is available to you. It's a mix of Amazon gift cards, training and certification vouchers, all kinds of other stuff. And again, that's all available to you therein. All right. With that, as a reminder, tonight should be interactive. Certainly drop your questions in Brella, drop your questions in Discord. I will be monitoring both and delivering them to our guest tonight towards the end of his session. So with that, it is my pleasure to introduce Mr. Emmett Moore. Emmett joins us from Red Trident for a talk tonight on operational technology, and he is here to shine some light on something a little bit new from a kind of topic and theme perspective here with the US Cyber Games audience. and also to kind of break down some of the work that he and his team do in that space. So without further ado, Emmett, thanks for being here tonight. Thanks for your time. Looking forward to your presentation.
Thanks, Brett.
You can go ahead and throw those slides up whenever you're ready.
Yep.
And
Just making sure I just throw the right one up.
there they are. They look good. All
Sweet.
you, my friend.
Awesome. Thanks. So today we're going to be talking about kind of securing the future, the vital role of cybersecurity for operational technology. So some of this is going to be a little bit high level. I'll dive where it kind of makes sense to dive a little bit deeper. But if you guys want more depth into this, please throw those questions up. And at the end, I will dive as deep as you guys would like to go. So today we're going to kind of cover, kind of operational technology. What is it, right? I'm kind of walk through the different industries that exist out there, where we find the stuff, some of the current cybersecurity challenges that we're facing, the threats, the adversaries that are kind of coming after us. What are some of the biggest challenges that we have within cybersecurity for OT specifically, and why is it a little bit more unique than the IT side of the house? Then we'll kind of dive into some of the essential skills. So if you guys want to kind of continue the journey and maybe take a pivot from what you've been doing into kind of this operational technology side, some of the skills that are a little bit different than what you're probably accustomed to on IT and a lot of the stuff that you've been trained and learned so far. And then really, why does this matter within the US cyber games, and kind of some of the connections between team building and capabilities and kind of mentalities that you have when approaching these topics. And then I'll share some resources at the end and open it up to questions. So, operational technology, right? Operational technology is really it's everywhere. It's all around you. It's in all kinds of environments. You might not even be aware of it. So, water, wastewater, chemicals, manufacturing. If you're driving past a traffic lights are controlled by PLCs and controllers, and they're all communicated back. Wind turbines, making steel, making products. Most of the stuff you have in your house was made by a manufacturing piece of equipment, which is operational technology. So anything that pretty much makes, controls, or moves something, is operational technology. So in the end, people always kind of ask, okay, well, some people say IT versus OT, internet technology versus operational technology. It must be this different thing. And really what it is OT is really more of an ecosystem of technologies. There's engineer workstations, like here in the middle on level 3, there's an EWS. There's supervisory control and data acquisition SCADAs. There's HMIs, PLCs, RTUs, DCSs. There's all kinds of acronyms out there of what these are. But essentially what it is there's a guy that's an engineer. He designs the system and he uses a computer to program or configure different devices, whether that's a human machine interface, he'll make a graphic, a SCADA system, which connects to a lot of different controllers and brings back data, and visualizes in a different way. Or if it's done on the control level 1, or even smart instruments like robots and different smart meters that we have out there. So when you think of it, kind of, I mentioned earlier that hey, there's a lot of technology, or there's a lot of stuff around you. The soda cans, pop cans that you have, the tap water. When you turn on water, it's coming out because of another plant that's running a bunch of process. Making your cell phones, snacks, all these things are kind of created by industrial automation or industrial control systems, which is operational technology. Even the things that we kind of take for granted, like the gas station, the tank that actually has the fuel in it uses a controller that comes to the gas pump that actually comes to your car. Traffic lights or traffic detection systems or air traffic control, right? All the radar telemetry and ATAC and all that stuff is all, kind of controlled by these control systems. And then some of the critical ones that we probably all hear about in the news, like lights, electricity, power generation, substation, distribution coming to your house. But probably one of the biggest that people don't realize the value that we have in the United States is really the transportation side, right? Which is either doing a pipeline, airlines, vessels coming in, unloading of those vessels, or trains kind of moving around, mass amounts of commodities being moved around the country rely on operational technology. So kind of diving into a little bit more of the nuts and bolts, right, between IT and OT. The operating environment. So when you think of IT, you think of, I think of a computer at home, your cell phone. I think of a server rack, a data center. They're really about moving data. If my email gets to somebody 30 seconds, 1 minute late versus me sending it right away and getting there, that's not a big deal, right? But in the world of operational technology, if I send a packet and that packet never gets there or it doesn't get there within a determined amount of time, that is a very bad thing, right? We actually have watchdog timers and things like that will go off and either halt the process, kick it into a safety shutdown, or do different things just because a single packet didn't get to it in time. So the operating environments are typically, clean on one side for IT, but on OT, dirty, horrible. I'll show some pictures here in a minute that they've been kind of cleaned up, but a lot of it is these systems sit out in the middle of a factory for 5, 10, 15, 20 years. Some of them are older than I am, and they just are not taken care of, right? So the technology has to be able to live in that environment and sustain itself. You know, IT COTS, right? Commercial off-the-shelf technology. So again, it's buying that simple laptop, a little desktop server, or a rack mount server. Those are easy to purchase. They're configurable all the time. They kind of work a certain way. But in OT, it's really more about proprietary. A PLC from Siemens versus a PLC from GE looks different. It functions different. It's programmed differently. The interfaces are different. So there's a lot of kind of proprietary protections within OT, which makes it difficult for us from a security perspective. But from them, it's been built over the last 40 years or 35 years, kind of with that aspect of them protecting their IP. The designs, there's a lot of interoperability between IT. So, if two people have two cell phones, we want to be able to exchange images back and forth, share pictures, right? Share contacts. If you have a laptop and you want to email somebody, you want to be able to use the same, application, or be able to at least email somebody that's on a Windows to somebody that's on a Mac, right? We want that systems to kind of interoperate. Within the OT side, we have to build that interoperability, right? Things don't just plug into and play together. We have to design them and engineer and make sure that they test out well. And every single communication that it gets exchanged between, say, this HMI that was above down to a PLC, those communication payloads are actually designed and engineered and implemented versus just check the box and we're chatting back and forth. So there's a lot of kind of design that goes into play in OT versus IT. It's kind of done for us when the application was built. Life cycle, like I talked about earlier, life cycles are 3 to 5 years, right? For technologies, most of us get a new laptop every couple of years. Cell phones, we replace them every couple of years. Obviously they offer the plans from T-Mobile and Verizon to be able to replace your phone every year with the newest and latest and greatest. Operational technology, it's decades, right? We design these things at least a minimum of 20 years to last. And so when you think of what type of technology was designed 20 years ago compared to today, and what security controls it had back then versus today, that's a huge stark contrast between where we kind of think today. So there's a lot of challenges within that realm that we'll talk about in a little bit. And then kind of priorities and operations. Like I was talking about, if I send an email or I send a file and I transfer that file somewhere and it takes a minute, 2 minutes, 5 minutes, 20 minutes, it's not the end of the world, right? It's not going to shut down a business. But in operational technology, if you do those things, we measure packets by latency and jitter, right? So if it's got less than 10 milliseconds, it's got a 1% jitter on it or 10% jitter, that's allowable. If it's informational packages, it's 100 milliseconds with 10% jitter. Like, we measure the time and the delay on those packets. That's how much of an importance just a single packet is for us. Regulation compliance, there's a lot of compliance on IT side as well as OT. OT is getting better from a security standpoint. but there's a lot of design requirements. So when we start talking about 61131 and there's different technologies of how to program a PLC or a controller, there's guidance there, but not necessarily around a bigger picture like Fin. So these pictures obviously don't look like a server, right? They don't look like a computer you guys are probably used to seeing. If you guys have played with like Arduinos and microcontrollers and things like that, they probably look a little closer, but really they're different. So most controllers and operational technology that you're going to find is going to kind of look like this. It's going to be some modular type of control system that has racks, these modules that slide in and out. And those modules are designed to be configurable, where you have some are for inputs, analog inputs, digital inputs, different types of electrical values, and then some are designed for outputs, right? Whether they're analog outputs or digital outputs, and different voltages and different amperages and different techniques like isolated versus non-isolated outputs and groupings and things like that. So when we're building, say we're building a power plant, all the different motors and valves and control systems and drives that make the whole process work, we build that into an IO list. And then from that IO list, we reverse engineer and say, okay, this is how we have to build our control system. And then we use things like control narratives and documentation to really design the rest of the controller to be put in this facility. So you can see some of these pictures have a lot of wires kind of going around to fuse blocks and to terminal blocks. And that's because those wires are being protected before they go to the controller or before they go to the field or their power generation or power support for power supplies. So there's a lot of sort of electrical engineering meets, control design meets process engineering within this. And then it gets even more exacerbated when you get into the field of actual the process control of what you're kind of trying to control with the process through it. So it looks a little different, functions, it's industrial rated. So why is it important, right? Hey, if these controllers go down, what's the big deal? Well, the big deal is, we'll kind of walk through a scenario of the interdependencies that kind of exist between the different industries that all have supply chain risk on it. So imagine today the lights go out, power just went out. Okay, well, if the power goes out, I can't move my process, right? So my pipelines, they're not going to be pushing gas, or they're not going to be pushing oil or chemicals through them. They're not going to be moving product. And so if I'm not using fuel, now next thing you know, I don't have fuel for my rail system. I don't have fuel for the ships to unload. The container cranes aren't going to be operating. Next, is the airlines, air traffic control. Airlines aren't going to have fuel. So immediately, within just a little bit, our supply chain, for our fuel side, becomes a critical point of attack. That hey, if I lose power, I can't get these things to function. What can I do? And then it just kind of trickles down from there. You start losing water, you start losing factories, and it becomes kind of a bigger chaotic piece as it just trickles down. So a loss of one industry can impact other industries because you can't move commodity, you can't move fuel, you can't move things that we kind of rely on. So, okay, we talk about operational technology, we talk about what it is, we talked about kind of the nuances, but what's the reality, right? There's a lot of FUD out there, fear, uncertainty, and doubt of what type of tech adversaries are coming after this. Are they really getting impactful? If you Google OT cyber threats, you can see every year everybody's claiming that it's going up and up and up. And the reality is it's not only going up and up and up, the adversary is getting smarter each year, right? They're learning about operational technology. They're learning, just like you guys are on this call, having these conversations where we're talking about what is it, how do these systems work, how can I compromise them, how can I impact the different operations. And so, like going through here, in 2021, we had the Colonial Pipeline attack. So if you lived on the eastern seaboard of the United States, you probably remember this one, where basically the fuel pipeline for one of the largest suppliers was shut down because they were attacked on the IT side, but they didn't know if it impacted the OT side. And so, out of safety and out of precaution, they shut down the operations of moving fuel on that pipeline, which impacted a lot of people at the gas pump. That same year, we also had several other high-profile attacks. We had the Oldsmar water attack down in Florida, which a remote access server had been left open, and they were trying to get in, and somebody had actually gotten in from some old credentials and used some, got into the SCADA system, and they could modify the sodium hydroxide to put more caustic chemical inside the water and potentially hurt people. They detected it early, so it didn't hurt anybody. But the fact that it could happen straight after that Colonial Pipeline attack was kind of a big deal. That same year, you also had JBS Food was compromised, and they had some contaminated meat, I believe, off that factory. Now, this year, or a couple years ago, and even existing to today, is Volt Typhoon, right? So here in a second, I'm going to show you a video kind of talking about Volt Typhoon and kind of the details of it. It is probably one of the biggest risks that we're facing right now, and it's a great example of how the adversary has really gotten smarter and is also being sophisticated in their type of attacks, right? So um, I'll play the video now.
Hey, Emmett, I'm not hearing the sound on my side. I don't know if there's a.
Okay, you don't hear it?
I do not hear the sounds.
Okay,
If
that's what I
you
was worried about.
is there a link to that?
Uh, there is. I can put it in and send it to everybody afterwards.
Yeah, cool.
Or,
That would
or
be
do you want
fine.
to play it?
Yeah, and I can share it out too.
Okay, perfect.
If you want to play this and just kind of narrate over it, that would be fine as well. Otherwise, back to you, my friend.
Yeah, I'll throw it and actually talk about it. So we'll go back. So Volt Typhoon. So here's kind of what Volt Typhoon is, and this is interesting. So the Chinese, right? So obviously in America, we always talk about Russia, China, North Korea, Iran. In this case, China did a multi-year assault against some systems within our critical infrastructure. They compromised power generation, telecoms, um, water treatment facilities, a whole list of assets. And so what they did was they actually were able to compromise some old technology routers that lived in these environments. And since these environments haven't been maintained very well, a lot of these routers were kind of sitting there dormant and they weren't used anymore, but they were still connected to the networks. And they had vulnerabilities in it. So in 2019, several vulnerabilities got disclosed about these old Cisco routers that were sitting out there. And essentially, they were allowed to be able to pivot through those routers to get access to a network and be able to understand all the networks have access to the router at an admin level, essentially, right? And so the big thing is China for years and years and years has been doing more espionage and stealing intellectual property so they could take it back to China to make it in their manufacturing facilities, right? So they could learn how we did things and went back and actually did those things back home. Now, this was the first time that we've seen them come into an environment, not disrupt it, not steal data, not with the intent of actually, having the espionage side. They were there to wait for a geopolitical moment where they could actually inflict disruption, right? And that's the big risk, right? Within operational technology, when we talk about the lights going out or fuel not being moved or transportation being shut down, the risk is from a geopolitical standpoint, from a government standpoint, if another government can kind of inflict pain, into our critical infrastructure, into commercial businesses, that causes a lot of disruption, right? That causes an unbalanced chess match when it comes into the world politics, and so that becomes kind of a national security issue. And so Volt Typhoon, thankfully, we caught it before it was ever kind of used against us. But the fact is, we don't know how big of a risk this is, and it's a really hard problem to go fix. And we'll kind of talk about that in just a minute. So I'll jump over this video real quick, and then we'll kind of continue on. So, talking about why it's so difficult, right? What's the challenge within this space? Why can't we just go put some EDR and endpoints, and why can't we go run Nessus against it and harden everything and put the right security controls and tools like we do on IT into these OT systems? I mean, they're just technology, right? Um, the challenge is it's not that simple. And we'll kind of go through some of the details, but really, you know, it's challenging because in order to really understand the problem, you need multi-domain understandings, right? Like we talked about earlier, you need that electrical engineering knowledge, you need operations to understand what are you actually doing, you need process knowledge, um, you need a lot of information around, engineering and security, just to have a meaningful conversation that you're not actually going to cause more damage to the process by securing it than you would if you just left it alone. Systems lack a lot of cybersecurity controls, which we'll talk about. The time and money to fix flaws is difficult, especially for a lot of critical processes that run 24/7. Shutting something down is not something you just uh, decide tomorrow that, hey, tomorrow we're shutting the process down. Some facilities, they can be, like a lot of manufacturing facilities, they have 2 shifts, maybe not 3 shifts, or they run 3 shifts during the week and they shut down on the weekend. Those processes are a little bit easier to do patching and modernization efforts. But things like oil and gas, refining, transportation, systems that are just constantly being used, it's a little bit harder and more planning is required. And then there's the whole lifespan aspect. These systems were designed to be for 20 years. So when they invested into the system to have it run and do what it's doing, they design it not to really be touched, for those 20 years. They didn't design it that, hey, every month you're going to have to do a bunch of patching, or you're going to have to do segmentation, or you're going to have to do a bunch of management on top of it. And then really the trade-offs in operating systems. So we haven't dove down into kind of deeps of OT versus IT, but one of the big differentiators is really OT uses a lot of real-time operating systems, RTOSes, versus more x86 like Linux and Windows and Mac. There's a whole different kind of side of the operating systems that we work with. So the need for domain understanding, right? So kind of talked about with the ops, maintenance, engineering, security. If you're going to go in and understand, or say you go do an assessment, right? We go out and we do our scans, and we understand how the network's working. We do our packet captures. We understand how things are communicating. We understand the physical and logical network diagrams and all the assets that are on the network. We have a really good understanding that, and we want to re-IP the environment, right? We say, hey, look, everything's a flat network here, which is very common. We want to re-IP it and do a segmentation, put some VLANs into it and things like that. That is actually a really big, difficult task, because all these systems were designed to communicate to each other, and some of the technologies, some of the protocols we use don't actually work at a layer 3 level, right? So they don't work when they start going across the network stack too far. So you have to really design it well to think through, okay, what protocol do I have? What capabilities are we working with? How much re-engineering are we going to have to do on the control system side to make it work? The networking stack, what's my network infrastructure going to have to change? And then planning that with operations that, hey, we're going to take your facility down for, say we pre-plan and we get everything kind of redundant. Maybe we take them down for 15 minutes or 5 hours. How much loss of revenue is that facility in that couple hours that you're going to have them down? And if something goes wrong, how do you get it back? I'll tell you, one time I got called out to a facility that they'd been down for 3 days. A guy had 11 months to pre-plan everything he was going to do. 3 days into the job, the customer didn't know when the plant was going to come back up. It took us 31 days to recover the facility after this guy had gone out and taken 3 control panels offline, gutted them out, so took all the different instrumentation out, put new stuff up. It took us 31 days to redesign and engineer and fix what he had done. He had 11 months to plan. We had hours. So making changes within the environment is something that's kind of a big deal, and there's a lot of safety aspects to it. So it's fun. It's fun to work with a whole team of people, but it can be challenging because they all look at it from a different perspective, and sometimes security is not the most important thing to them. There's a lot of proprietary stuff, the code, the apps, the protocols. when you're working with, say, GE, Siemens, Rockwell controllers, they all have different IDEs that have to be used to control their controllers, or their programs. Or if it's a uh, wonderware application for HMI or a SCADA system, or it's Rockwell's Shock View, these different products require different development licenses, which are very expensive, to just build the application. And then you have to get the application to actually run on the whether it's a Windows system or whatever. You have to configure it, you have to harden it, you have to do all these different things, and every single one is different. So if I go to GE and I harden a system for GE's PME software, the same hardening guide and the way I do it is going to be almost completely different to what I do for Rockwell or somebody else's technology. So there's no repeat across the board, of being able to do this. So the proprietary aspect becomes just kind of it's a pain. Every time you turn around, you're always having to deal with this problem. Um, and then you have protocols. Now, thankfully, we're getting a little bit better in this regard, but probably in the 1990s, there was probably 140, 150 different proprietary protocols, if not more, that just everything under the sun. We hear Modbus today, but even Modbus had like 25 different implementations of Modbus, and they didn't work together. So one vendor had Modbus this, another one had Modbus extended, one had RTU, and so trying to get all that stuff to work together and design it and engineer it, and then you want to make a change to it, becomes very difficult. And then we have the most difficult, probably cultural barrier that I run into a lot of times is security. Probably 10, 15 years ago, when security really started implementing, maybe even 20 years ago, security started implementing changes within operational technology or within OT or ICS. They did it poorly. They did it from an IT perspective. And so they went in and put in things like antivirus on an HMI or antivirus on a historian or an engineer workstation, which stopped the system from working. So 3 o'clock in the morning, a plant's down, somebody gets called out in the middle of the night, he comes to his job site and he tries to log into his engineer workstation and he can't. And he tries for hours and hours to try and get an application to run that just ran a couple days ago. He hasn't touched this machine and it just won't run. And so in the morning, 8 o'clock, when IT finally shows up, right, he's able to talk to IT or IT security, and he's able to get into his, and they said, oh, we pushed a patch yesterday, or we pushed a patch last week. And that patch, ended up taking his technology or making it so it didn't work the way it was supposed to work, or they hardened it and put whitelisting on it, and some change happened, so all of a sudden his stuff didn't work. Now he's got to justify to his boss that why 3 o'clock in the morning until now he wasn't able to recover the facility or to fix whatever problem was happening. And that animosity over time between operations and security sort of prevented security from ever being invited back to the table within operations or within the industrial control. And so a lot of times when we go out there, we have to kind of dispel that we're here to disrupt things, that we're really going to work with operational teams, to help them. But it's a big barrier for advancing cybersecurity in our realm, even though technically it's not the challenge. And then really, blue team is valued more than red team. So there's probably a lot of people on this call that are savants when it comes down to the red teaming side, reverse engineering, capture the flags, things like that. But with an OT, those skills are amazing and great, but there's a lot of vulnerabilities, just like Bolt Typhoon. Vulnerabilities had been in systems for years and years and years, and nobody had ever fixed it. The problem is the blue teams don't know how to fix it. They don't know what to do to fix the problems sometimes, or they're so inundated with so many vulnerabilities and so many problems that they're kind of just stuck. And so there's a lot of value being pushed more on the blue team perspective, or even a purple team approach, which is the best approach, right? Is the purple team. But the blue team skills of defense and how to implement change within these environments is really a big deal within OT cybersecurity. Lack of cybersecurity controls. So, PLCs are designed to run a process. Control systems, DCSs, SCADA systems, they were designed to run the facilities and run them over and over and over, consistently, predictably, for a long amount of time. What they weren't designed to do is do security. So most PLCs, other than the latest and greatest, don't have basic level authentication capabilities. So what I'm saying is like if you literally go load Rockwell's RS5000 onto your computer, and you go out and you actually go try to connect to a PLC that you've never seen before, it's in a plant, it's everything, you can just plug in, connect to it, and see the whole program. There's no authentication, there's no password, there's no even single factor. There's nothing. There's nothing there. Most of our protocols are also non-encrypted, so everything's kind of in the open. You grab Wireshark, if you can tap a line, you'll see every command, every packet going across. If you want to inject something into the line, you can inject it and you can compromise the system. So there's really, it's a very, very soft environment. So we do a lot of perimeter protection. We do a lot of other controls kind of around it to kind of help the environment. But at the end of the day, these the technologies were designed 20 years ago, and even the new stuff coming out, a lot of it still doesn't have the level of security that you and I would kind of expect to see. IT security, we talked about the example of antivirus. Now it's kind of anti-malware, XDR. A lot of that stuff, when you deploy it on it, we don't use IPs the same way that IT does. So we're not looking at packets that are going out to some malicious IP somewhere else or downloading stuff directly into the environment. So there's no real threat intel or OSINT that we can kind of do on a lot of our packet levels to kind of look for these risks right off the bat. Right now, some environments that are super immature where they have an ISP connected right into the OT, yes, there's value there. But a lot of the security controls that you would kind of expect to see, endpoint protections, network monitoring or network protections, they don't really work well with an OT unless they are designed for OT. So, going back to those protocols, if you're doing IDS, IPS within OT, you need to understand the industrial protocols that are being used across that environment, how actually the datagrams and for that protocol is kind of structured, and where is the data for that protocol? Is it in the payload? Is it within the context of the rest of the datagram? A lot of these protocols are actually serial protocols that have been encapsulated into TCP, which means that in the data payload, there's another protocol there. And so, can you manipulate that inside protocol to be compromised and still have the packet look normal and compromise the environment? So not all IT security controls kind of work well with an OT, which makes it kind of complicated. And then, you don't need a vulnerability to understand compromise OT. There's a video my team did back in 2013. Brian Meixel and Eric, one of my other guys, I don't know, Eric somebody, from years ago, that they went to Black Hat. We put them at Black Hat to basically show how we could put man in the middle on a Modbus protocol and not compromise the PLC and not compromise an HMI, and to be able to inject the attack from the payload standpoint of the HMI showing everything's good and the PLC is overspilling. In this case, we actually sprayed the whole crowd for what we were doing there. So the big part there was, we're not using vulnerabilities in these environments. So while you'll hear the concept of hey, patch it, just go in and patch the environment. Even if I patched every single system in OT, I could still compromise it. So we're always compensating, right? So the cybersecurity controls is we're trying to always find that compensating control because we can't patch it, because we can't do this, because we can't do that. So it really means that, if you're a true practitioner of cybersecurity and you understand the controls, what is the compensating control if you can't do password complexity on an endpoint? What can you do otherwise? What is the risk, right? What is the intent of that control, and what are you trying to accomplish? And is there other controls you can put in place, whether it's 1, 2, 3 other controls, to compensate for the lack of that other control? And that's a lot of what we do. A lot of my guys do. Life cycle. So long life cycle interoperability. So vendor lock-ins. We talked about GE, once they have a proprietary hook into you, or Rockwell or Siemens, it's kind of difficult to move just to another one. It's not like if you go buy a Dell laptop and you say today, it's slow, the battery sucks. Let's switch over to something else. Um, you know, it's not easy. You can't just go to an HP or Lenovo or whatever you want because you want to. It's a huge engineering redesign within the environment. So it's kind of a problem. Um, the long life cycles means that, hey, the system was designed to be here for a long time, and that's kind of they say, well, it was designed to be here 20 years. We're only 10 years in. I'm not going to replace it. It's not broke. Let's not fix it. Um, and that's where the profit versus security kind of comes in, is the fact that you have this. Well, we're trying to be profitable. We designed the system, spent $1 million on it. We're still making our money back off of it. And now you want me to invest another X dollars per year to handle the cybersecurity thing. What do I do? And so a lot of businesses kind of juggle that dichotomy that exists there between making money and spending more money on the process to make sure it's secured so that it keeps making you money. And they just don't. Sometimes it's a difficult conversation. And then when you upgrade one, upgrade many, right? So back to that vendor lock and kind of the ecosystem products. Just because I want to upgrade one GE, even to a newer version of a GE, a lot of times there's feature removals. So maybe they get rid of an old protocol that I'm using. Well, if they're getting rid of that protocol, now I have to change my HMI. I have to change my historian. I have to change my other things. I have to change my sensors down below. So now I'm upgrading a lot more things than just one technology. I'm having to upgrade many different technologies within it. So it kind of pushes back to the business to say, hey, this seems really expensive, really complicated. I thought I was just going to do one thing. Now I'm doing five. Maybe I'm not going to do this. Or I'm going to wait a little bit longer to do this, which then leads them open to attack for longer. And that kind of comes into the dollars, right? So redesigns, upgrades, cybersecurity tools, it's one thing if you were just doing a patch, but with an OT, when we patch the system, because those features kind of change sometimes, you have to get a system integrator and engineering group in to validate the change, to make sure it works again, retest it, push it to production, monitor it for a little while, and then you can say, hey, everything's thumbs up, let's go, and away we go. But that's extra money, right? It's not just rip and replace and go throw a new one in. You're actually having to do a lot of engineering work that adds overhead on top of that. Same thing with upgrades, whether it's redesign or upgrading, it all kind of comes to that same boat where if you're redesigning, do the network architecture changes, or you're doing the upgrades of just a single device, it costs money. And then what do you get? So you upgrade a technology. Well, are you telling me there's never going to be a vulnerability in that technology? Like, we all know that's not true. So now what do we do? And then, as I talked about, kind of any change requires multi-party review. When you are upgrading these things or redesigning it, everybody's going to get a say at it. So it just takes more time, takes more money, and ultimately, sometimes you're not getting as much value as you think you are off the initial part of the project. So, now that we've kind of talked about all the different challenges we have, what skills do you need to have to be able to come into this environment and actually be successful, right, within OT cybersecurity? Really what we look for and what we talk to people that are coming to the company, or when I talk to other folks and younger folks that are kind of coming into the industry, there's a level of knowledge that you kind of need to have, and there's a kind of an attitude, right? The passion piece that's there that we're looking for. So we're always looking for, do you understand the networks? Do you understand networking within the operational technology and some of the challenges that are there? It's mastering the fundamental pieces. We're not looking, hey, can you go set up a BGP? Can you go build a whole network architecture right off the bat? Like, no, but do you understand what packets are? Do you understand how to use Wireshark? Do you understand how to do some of these things? Do you know how to do integration? What is engineering? What's their role here? Assessing security, defending it. Do you know the difference between those things and how to do them? If so, that's a great foundation to kind of build into an industry, whether you're working in oil and gas, chemicals, energy, transportation, manufacturing, they're all going to be a little bit different of how they do these. But if you know the fundamentals of those, it goes a long way to helping you kind of understand the uniqueness of OT. And then another part is really being a team player. Uh, I'm a Marine, right, by background, and as a U.S. Marine, kind of teamwork is a huge part of me, and it's a huge part of my team here. And really, the goal is to bring other people to security. You are going to be the biggest champion inside a company of security. So your ability to go out and talk to people and bring that passion in and bring people to the table that want to understand it, and they don't look at it as this thing that's going to prevent me from doing my job, right? Because that's what everybody thinks. As soon as you walk in and you say, "Hey, I'm security," they're like, "Oh, you're going to lock my laptop. Oh, you're going to stop me from doing my job." Don't be that guy, right? Be the one that partners with them and says, "No, no, no, no. I'm not going to stop you from doing it. I just want to make sure you're doing it securely." And yeah, there's a lot of conversations they're still using, Telnet, to make modifications to a switch infrastructure and stuff like that. And you say, "Hey, can I switch you over to SSH? Can I do this?" Like, you teach them and educate them, but bring them in, right? You're that person that can kind of bring them in. Um, Sharing your knowledge, learning what they know, learn how to do what they do. If their operations, their maintenance, what do they care about? Are they worried that in 3 o'clock in the morning you're not going to be there to help them, or are they worried about something else? What can you do to understand them to kind of help mature them from a security standpoint? And then one of my biggest words that I use, probably the last 20 years, is Semper Gumby, which is kind of always flexible. It's a play on the Marine Corps term of Semper Fi, but Semper Gumby, always be flexible. A lot of security people will walk into a room and think that, "Hey, I know what I'm doing. I know the vulnerabilities. I know what's right. You need to do what I say." Um, the biggest, hardest problem is that a business has choices. And so the community, if you're working for the company, everybody has choices. And so being flexible and saying, "Hey, maybe I'm not going to win this battle, but I'm going to try and win next one." Or I'm going to try and educate them so they see what I see. That's a big part of cybersecurity, is getting people onto your side where they become the champions of security, and you're not having to push them, but you're walking with them. Kind of diving a little bit deeper. So, how do you do these things, right? From a networking perspective, what are you looking for? What is the network fundamentals that people really need to have? Well, we've talked about these unique protocols: Ethernet IP, DMP3, Profinet, OPC UA. A lot of these things, knowing the network protocols at this level 1, are going to be very, very proprietary to kind of OT, or not necessarily proprietary, but they're going to be very unique to OT at this layer, right? So if you ever get a chance to, you can Google it and you go find some packet captures that have been done in operational technology. You can get some Modbus traffic and Ethernet IP traffic and things like that. Open it up in Wireshark and look at the difference between maybe you taking a packet capture at home and seeing a lot of your HTTP traffic and HTTPS that's going out, and see what it finds within those packets when you open it up from a download of a level 1 packet. They look a lot different, right? They're unencrypted. You can look at the whole payloads, but the structure of them is also different. So being able to use Wireshark, and Wireshark even natively doesn't really understand all these protocols all that well either. So sometimes you have to put different plugins and things like that to really get better at it. They've matured it, so most major protocols are well understood with Wireshark now, but still, it's improving. Same thing with Nmap. What do Nmap scans look like when you scan a PLC or an HMI that's been configured? What happens when you find different protocols that aren't what you're used to, and what are the responses and callbacks? That'll be a big thing, that understanding with an operational technology, what does it look like, and how can you learn from that? Same thing on the next level, right? HMI to SCADA, you're going to see a lot more blend between IT and OT. So you're going to see that industrial protocol coming from level 1 up to an HMI. But if it's from an HMI to, say, the historian, or an HMI to an application server, it might be more, HTTPS, TLS, kind of communication streams that you're used to, and you can dissect those and kind of understand them. So it starts blurring a little bit at level 2, and then really level 3, most of this stuff is going to be more IT-ish, Not all of it, because then your workstation can come all the way down into level zeros and ones. But you're going to see a lot more traditional communication streams that are kind of going back and forth. So even within OT, we have a blend between OT, IT, IoT kind of protocols mixed into it. So it's good to know how to use the tools and just get familiar with the difference, of DMP3 or 61850 or Goose. What are these things and how are they structured? And then overall, what? Yeah. So systems knowledge. So this is kind of one that is passionate to me. So if you come into OT, you might understand the protocols because you're able to kind of learn it. You learn a lot about the different technologies. You're able to take courses. Go get your GICSP or go get different SANS courses or ISACA courses, or just open source courses, whatever. But knowing the actual systems and what they're doing and kind of how they do it is a huge value add, right? So, playing with things like an Arduino, a microcontroller. How does a microcontroller actually work? Like, get into the guts, just like you do if you're taking a badge and you go to DEF CON and you take a badge and you want to hack the badge challenges. Getting in and understanding how do I get code off of the microprocessor, right, off of my chip. How can I do it? Do I have to float pins? Is it natively hooked up? Can I get a JTAG port to it and pull things out? Knowing how to do that within OT and starting to learn the fact that most of the time you're going to have to disconnect pins that have been wired up to be able to do that unless you do it the right way, the way that the system was designed to be doing. That's the only way to kind of hack these controllers. And so that becomes sort of a unique process within OT of how is the code being compiled and put onto it? Because it's compiled code that runs on these. It's not, and you just configure certain parameters within it. But the real-time operating system runtime environment is already loaded onto the controller. So much like how a microcontroller and Arduino is. If you want to go more advanced and kind of have a little bit more fun, you can take like a Raspberry Pi and do CodeAssist PLC and put I think it's like 10 or $15 to run the actual real-time license on it. And then you have a full PLC, right? In essence, it's not deterministic, so it's not perfect, but from a coding perspective, ladder logic, structured text, sequential function blocks, how to program a PLC. You would learn a lot of that. You'd also learn using CodeAssist IDE, hey, how to connect to it, how to download the logic to it, how that all works, how to connect to another Raspberry Pi. If you build two of them, you can have them communicate between each other. And sort of how does that work? And so you're starting to build that ecosystem of a system of systems knowledge. And it really helps you understand how these different components have to be done within OT versus in IT. A lot of stuff is interoperable, right? It's exposed. There's APIs. There's different interfaces that make it kind of easier. Our world, there's not. You have to hard code almost everything. So, things like going from the engineer workstation to HMI. How do these things communicate? How do they work? How do you download? How do you load them? How do you build them? And then if you want to go engineer workstation to the PLC, what's the difference between building an application for the PLC or RTU versus building an application for the HMI, right? And how do those operate? And then when you download to them, how do you get the two to actually communicate to themselves? And then same thing with going all the way down to a robot, right? You might program the robot, but the robot's not going to be run by the engineer workstation. It's being run by the PLC. So you have to get those two devices to talk through you programming each one and then making sure that they work. And if you've worked with microcontrollers before and you've done a lot of controller to controller communication, you'll understand this. But if you haven't, it's a really good experience to kind of go through and do that because you end up finding out that you're working through another system to make that system work to your application. So troubleshooting, making changes and stuff like that isn't straightforward like you would expect when doing like an IT application program. Risk management. So not the sexiest job out there, but it is one of probably the most valuable jobs within OT. So everything within most businesses is about risk management. So in this case, I asked the question of, would I fix a CVS's 4 faster than a CVS's 10, right? And in some cases, if I had a 10 that is down at level 0, which a lot of them will probably exist down there, um, versus a 4 that's sitting at, say, level, yeah, my DMZ, I'm probably going to fix my 4 before I fix my 10. Just because one, I sort of have a bunch of levels and defense and depth strategy that here that's helping mitigate the risk. So my overall risk score would probably be lower than a 10, um, even though the vulnerability itself is a 10. But my 4 up top might pose more value, more risk to me as a business. So understanding risk management and sort of how that works within business and why we would go one way or another is a skill to still understand. So it's not just, hey, I have a vulnerability here, I need to fix it. Well, what does that vulnerability mean within the context of a business? And then kind of going back, we're talking about multidisciplinary understanding. So again, you've heard me say this over and over time about interoperating between engineering, maintenance, operations, security. That this multidiscipline understanding really is the backbone of OT cybersecurity. IT, you can sort of if you're running in a SOC and you guys find a vulnerability, you can push it out to engineering. They're going to go out and fix it, and you see the vulnerability go away, and boom, it's pretty simple. You don't even have to get the end users involved. Within OT, you always get the end users involved, which is typically operations, right? You're going to talk to operations, say, hey, we've seen this thing, we want to fix it, we want to do something about it. Here's what we want to do. They're going to check it. They're going to dissect it and try and understand, is this going to be an impact or not? And it's going to be this circle that just goes around and around until everybody's happy with it. Because at the end of the day, if something goes wrong, it could be the worst. Could be the process stops, or the best situation is the process stops, or it fires off alarms and things keep running. The worst could be in some environments it could go boom. It could stop running. It could like if you're a large refinery, if it stops running some processes, it doesn't just start back up. It takes sometimes days, weeks, months to restart a process. So it can be a very disruptive thing of having a downtime. So learning how to work with other people and other skill sets that don't understand cybersecurity is probably one of the biggest challenges I've seen people come from with traditional cyber backgrounds into OT is people are just not on the same level. And then here's kind of my favorite, right? Bring your kung fu. The multidisciplinary teams, the build resiliency where you can. The 2 is 1, 1 is none. Adage is really around when you're thinking of defense in depth or zero trust architecture or whatever you kind of want to call it nowadays. A lot of it is all really focused around building that resiliency into operations. If I lose a switch, is it going to kill my whole entire plant? If I lose a processor, if I lose an HMI, if I lose something, if I lose just one, is it going to take my entire process down? If the answer is yes, and it's a critical process and it's worth the money, then build 2, right? Because 1 is really none. Something's going to take it down. Whether it's a lightning strike, whether it's a backhoe digging up a fiber line, whether it's a cyber attack, whatever it may be, or a misconfiguration, something's going to happen to take the 1 down. Build it with 2. Build resiliency into it. So I share here kind of some training capabilities that are kind of out there. CISA, if you're not familiar who the Critical Infrastructure Security Agency is, they're the ones kind of responsible for pushing out new updates and regulations, not necessarily regulations, but new updates and best practices to the industry for most industries. So if you get a chance to kind of go check them out, they're really focused on critical infrastructure, which is a lot of the OT stuff. ISA, I'm on the ISA 99 committee, which is the people developing the 6243 standard, which is kind of one of the global standards for cybersecurity for OT. Great standard, has a lot of information designed for more operational personnel, but you'll start seeing the difference if you read the standards and specs of what that is and how it applies. And it kind of walks you through everything from assessments to remediation to program development across the board. And then SANS and ISACA have some really good training programs for OT as well. So how does this kind of tie into cyber games, right? So talked about the system to system, kind of high level stuff. It didn't dive too deep into technical capabilities of PLCs and hacking a PLC or something like that. But from a US cyber games, kind of how does this all work together, right? Collaboration. So when you're on a team and you're doing CTFs, like you might be amazingly talented and one of the best players on a team. But the reality is there's strengths of other people as well. And that's much like an OT where we have engineers, electrical engineers, mechanical guys, process engineers. They know more about the process in their domain than we do. And so it's okay to kind of turn to them and say, hey, what do you think? Or give a task off to those people. So the collaboration between OT and kind of cyber games being that team oriented mentality is really strong there, especially within operations. Evolving skills, OT systems are going through this rapid transformation between cloud and AI and the adoption of just new technology. A lot of practitioners, a lot of automation folks are really pushing advanced concepts of getting, controllers put in the cloud, instrumentation that's in the field, and sort of high-speed loops now that we have fast and resilient internet connectivity. Do we have to have a PLC on site? And in some aspects, you don't always need to. Um, in safety critical operations, yeah, they'll have them there. But can they offload some of the more critical processing or more big data processing, things like contractual rates or values or whatever it may be, off to the cloud or to a data analytics and machine learning thing? Um, and so the ever evolving skills kind of being adopted with OT is very similar to the cybersecurity challenges in cyber games of, CTFs are changing every year, new types of challenges that you're going to come after. And so you always have to have that kind of semper gumby on both sides of the house of being able to be flexible with new things coming out. So that, and then a high pressure environment. So if you're a athlete going after the gold, and you're trying to get that last flag, or if you're trying to defend against an adversary that's attacking your network and you're working inside a gas plant, both are pretty high pressured, right? So you really want to stay cool, stay focused, keep things moving, and just have that positive attitude that under pressure you can kind of always stay cool and still be able to do your task well is sort of a big deal with an OT, because if you're doing instant response or even just general daily cybersecurity housekeeping, if something happens, people are going to run around like henny penny and the sky is falling and we're under attack, and you're the cyber professional that can keep things kind of cool and say, hey, let me check it out, let me go through my steps, let me see, and then you'll determine that, hey, it's just a driver that failed and it's not somebody attacking you. You're the one that kind of sets the tempo. So same thing within new cyber games. So that's kind of the end of my presentation. And I guess if there's any questions you guys have, ask away. There's nothing too small, nothing too silly. Please let me know. There is some resources, LabShock, OpenPLC, ICS Village. Go check them out. They're really good. Same thing with like ICS Malcolm and a couple other things out there. So yeah, back to you, Brad.
Emmett, thank you so much. Thank you so much. Lots of really good chatter, both in Discord. Pulled quite a few questions, and I've been throwing them your way in the Zoom chat here. So let me just kind of cherry pick a few for you. Some of them from earlier on in your talk. What's the best way to shift from legacy OT systems to newer ones?
Ooh. I'm trying to think of how to shift from legacy to more modern. Um, Honestly, there's a lot of ways I could answer that, but I'd almost say iteratively. So you kind of step into the process, right? I think there's really two major approaches. You can go big bang and say, hey, we're going to upgrade everything and just cut it over. But there's a lot of technologies like Kepware, Matricon, kind of these middleware technologies that can help broker the protocol differences that often happen. And so it will allow you to kind of modernize one piece without modernizing all the pieces it means there's another point of failure. It means that you're having to engineer something into the solution that doesn't necessarily need to be there, uh, but it does allow you to sort of step into that thing. So I once upgraded a 1984 PLC. The manual was older than I was, which was awesome. I thought it was the coolest thing in the world. It had DOS system through it. But to upgrade it, we did that. We used Kepware as a middleware product to kind of broker the protocol, and then left the old controller there, upgraded the HMI because the HMI was failing, and then modernized one, and then they could plan for the upgrade for the controller later. So things like that.
Nice. Cool. Um, some of these you've answered. Folks are curious, is there a checklist that you go through when evaluating the security of an OT system?
There is. So there's sort of two different sides, right? Uh, there's the compliance side of the house, right? So if they're using compliance center like NERC SIP, if you're electric industry, 6243 is if they're more generic, which gives them a lot more flexibility in the controls. If it's DoD space or government space, you're going to have NIST 882, 853. Those will be a lot of checklists where you're compliant, not compliant, partially compliant. And then what we're starting to do is kind of pivot that a little bit when people aren't necessarily in a compliant industry. We use more threat modeling. So it's not necessarily something they have to do, but what are we doing to mitigate risk? So if you're looking at that attack surface and you're really a good practitioner of offensive side, that red team side, and you're doing purple team kind of teaming approach, red teamers are going to tell you, hey, these are all the ways I can get in, and here's all the things that I checked. And then you're doing your compensating controls and saying, okay, do I have my control in place to mitigate that type of attack or TTP that's kind of come in? And if you can, then you can do that checklist.
Awesome. This one you've kind of touched on a few times and relates back to the first question. In regards to legacy systems, do they oftentimes play well with some of the modern, newer technologies, or how do you continue to make them work?
Yeah, yeah, yes and no. Some stuff is the major brands have done a pretty good job on kind of keeping backwards compatibility with new stuff if it's within their brand. So say Siemens will have compatibility with maybe an older S7 controller, S7 300s, things like that, that they know are out there. They're still under support, blah, blah. But supporting, say you flip brand, you go from a Siemens to a Rockwell or Rockwell to Siemens or something like that, then it's going to be kind of a more of a jump ball um, within the control families. Now, where the real struggle is the end devices. There's a lot of meters that exist out there, like Bristol Babcocks and things like that, where they were designed, and I don't know why they did this, but literally, if they have more than one IP address, hits them with a TCP packet, they will knock offline. So if you ping them, you sweep it, it'll break it, you recycle the power, it'll start back up. Um, but when you think of legacy, modernizing a solution, how do you go from one controller to another without having two controllers connect to a meter and then be able to modernize it up? Um, and more of the modern stuff is more chatty than the old stuff used to be. So a lot of multicast stuff being kind of broadcast out there. So you just have to be careful of your network infrastructure to go through it.
Fascinating. Thank you. Um, how much of the job is writing documentation for OT systems?
uh, Depends who you are. Uh, so if you're more offensive security related, if you're red team, uh, kind of supporting more the assessment side, which I think is what a lot more people think is kind of the fun side of the business. Um, you're writing documentation around rules of engagement, what you did, documenting what you did for your assessments and your tests, and kind of turning that over so the other side of the house can pick that up in a POAM, plan of action milestones. Now, my governance side or a governance side of a normal house, if they're doing risk assessments, program developments, policy enhancements, whatever it is, they live and breathe documentation, technical writing, right? And so if you love technical writing, great, that's a job for you. But we're also starting to see a lot more um, packages kind of being put together. So we built some tools that allow us to kind of do risk assessments, and we're not having to write a lot of documentation. You're kind of filling in those organizational defined values unique to those policies or documents or poems, and so it's a lot less writing, and you're focused more on the value of risk and kind of doing a deeper dive into it. So it's starting to change, but it's traditionally been a lot of writing for the governance folks. Not my fan. Not my set
Right.
house. Not my
That's
favorite.
my
No.
that's my jam. That's my jam.
Yeah.
With supply chain attacks coming from APTs, for example, SolarWinds, Voltycoon, which you talked about, how can we minimize the supply chain attack surface?
Oh. Um, Really getting the OEMs to do a better job, right? So I was working. We do a lot of work with the government and the national labs and things like that, and having these conversations between uh, universities, academia, essentially academia, OEMs, and industry advisories, right? So people like us, the OEM, the end users, and it's this triangle that exists. So in order to advance technology, first you have to have a customer that wants to buy it, and then somebody like Siemens would go out and build it. Because enough customer requests came in that says, hey, yes, if we invest into this new feature, like adding TLS to our technology, then they'll go do it. Which means first you have to have a customer that's educated enough to know he needs it, which means that you have to get academia to teach those people that they need it to get the OEMs to do it. And that means, this circle. Um, that's not a very easy triangle to get rolling. The
It
national
takes a
labs
while.
struggle. Yeah, it takes a long while, but it also takes somebody kicking it off because it's sort of the cart and the horse. Who is going to do it first? Is it going to be academia spends the money to build the courses to educate people on something that they don't know they need, but they do need? That then is going to then ask for the requirements from the OEM. That then is going to go to academia to say, hey, how do I do it? Like somebody has to kick that off. And I think within cybersecurity, because in America we're more capitalistic, nobody wants to do it because it costs money, right? Now, once somebody has a breach, APT comes in and like a Volt Typhoon comes in, and the government says, hey, guys, we need to be doing this. That kicks it off. The insurance industry kicks it off. Regulatory industry kicks it off, right? Those people will kick it off and it'll go, and it's not about the money. But if there's really no capital value in it, then what I see is it kind of gets stuck.
Fair. Cool. Other than MITRE's embedded CTF, eCTF, are there other competitions out there that teach OT system security?
uh, Here's a plug for SANS. SANS has their piece out there, and they're training. The Net Wars. Um, if you go take the certs for 10 grand, I think it's highway robbery. To be honest, it's very very expensive, and most probably the people on this call aren't going to be able to afford a bunch of those certs. Um, I think that's a shame. There's ICS Village. Puts some training content out there and some ability if you go to DEF CON and kind of go see those guys, Bryson Bohr out there. Um, S4 is a really good conference to go to. There's a CTF typically there, and it's all OT people at S4, so it's a great opportunity in Miami if you want to go, like February, March every year. Um, that's a good one to go. Not only do the CTF, but also be around some other practitioners that are heavily OT cyber focused and they really know what they're doing. So
Yeah, cool. And I'll throw a plug out there. I know the Department of Energy runs their Cyberforce competition. I think that's limited to university students. I could be wrong about that, and I don't know how much you actually touch, some of the technologies that Emmett's been talking about tonight. But I know it is um, critical infrastructure focused, and has been for the last, I don't know, decade or so.
and there's
Um,
other things like Hack the Capitol going on tomorrow. So that one, there's Defend the Airport hack, which is next week. I'll be speaking at that one. So there's more industry specific ones,
yeah.
ManuSec stuff like that's out there. But yeah.
And there certainly could be a component too, and this is not my wheelhouse, so correct me if I'm wrong, Emmett, but maybe like bug bounties for car manufacturers and things like that might be a great place to kind of get your hands on some of this stuff and interact with some of these systems.
Mhm. Yep.
Um, How to get started with OT blue teaming? You've shared some resources. Any thoughts on that?
Oh, yeah. I once got asked, what is an entry level position in OT cyber look like? Right. And I put it back and I said, what's the entry level position look like in IT cybersecurity? Right. Do you typically just start as an assessor within IT? And some people say, well, sometimes, right? Um, Typically, you're going to come from some sort of systems background within OT. You could be a hardcore red teamer that's been doing IT side and wants to make a jump from IT to OT. Cool, come on. We'll teach you technologies, and a lot of companies out there will kind of teach you some of the unique technologies. But most of your skills and ability that you acquired are going to be useless, right? Which is disheartening. As soon as they get in, they're like, I've spent all this time building these scripts, and this works, and it's beautiful, and we don't have domain controllers. I'm sorry, we're not doing IAM in the environment. So a lot of the stuff that they're expecting to find to be able to pop and move around, within the environment aren't in OT. A lot of the endpoints don't have the same technology, so it becomes kind of disruptive. So what we find is typically people with automation backgrounds, where they've worked as a network admin, a system admin within a critical infrastructure company supporting OT applications. They've been exposed to these OT applications. Um, those people typically know enough to go, hey, I get it, what these things are. I'm really interested and I want to start learning more about it, and they can kind of liaison with their team. That's typically a really solid way to get some experience both on kind of the more traditional IT front, which is easy to get from out of school, and then make that flip over to OT cyber.
Sweet. Great answer. Thank you. These next two questions, I'm going to kind of link them. How does OT infrastructure defend against ransomware, and are there real-time protections for OT infrastructure, or does it depend largely on static defense?
Oh, uh, depends which level. So we use something called the Purdue model, which is kind of a reference architecture. It's not a security architecture, but uh, within the layers of Purdue, right? You 3.5 and above is all the enterprise class. We're not really doing a lot of stuff there, right? Down 3 and below. Um, 3 typically you can do a lot more IT-ish type solutions. So whether you're using like a dark trace or a whitelisting application or EDR, XDR, you can do it at those levels pretty easily most of the time. Level 2, it's sort of dependent. Some HMI software and SCADA software will allow you to do more. A lot more vendors have been pushed to have security hardening guidelines. And so you can still deploy, you see a lot of Trellix, McAfee, the traditional antivirus solutions kind of supported by the major vendors there. But you start dropping off some of the other more advanced, newer security controls that are more dynamic, right, in their capture capabilities. And then once you get to level 1, pretty much you see nothing but detection. So protection at 2 and 3, and really detection down at 1 and 0.
Right on. And there was actually a question here about the Purdue model. Seems like that's kind of the industry standard for your work.
Yeah, so originally Purdue came from like the ISA 95 model, which is based on manufacturing hierarchy. And so manufacturing hierarchy being you have lines, lines of equipment, and you have kind of a manager that oversees multiple units of lines. So that's a SCADA guy, supervisor control and data collection, right? So that's a SCADA, and then you have, a manufacturing execution system, which is the ERP system, or it's MES, but then there's the ERP above it. And so that's really where Purdue and ISA 95 are kind of sort of co-coupled. Then it's kind of grown since then, but that's kind of how it doesn't work in all industries, but it's sort of the de facto of like if you want to lay things out in a layer.
Cool. And then the last one, we've talked a lot about kind of modernizing the technologies that you're working with and what a complex process that is at many of the sites that you're operating at. Who are the primary stakeholders in OT infrastructure change, especially for security reasons?
Ooh, the gatekeeper's always operations. That they're pretty much, if they say no, you get a no. Nobody's going to trump operations. At the end of the day, especially if it's critical operations, the plant manager in operations has a responsibility to run a facility safely, right? If they think you're bringing risk into that safe operating environment, then they have every right to stop you. That's just the nature of the beast. Um, you are trying to protect them, but you have to convince them that they need to be protected, which is the challenge that we face sometimes. Um, so it's going to be operations. Engineering is typically involved. So if you're modifying a process or you're going to impact the process, some sort of process review, engineering review is going to be done. Um, Maintenance reliability will get involved. Does it impact long-term health and reliability of it? Um, and then it really becomes security. Sometimes IT will kind of get involved with like engineer, networking or system administration or application security, whatever it is. They'll kind of couple in, but I kind of couple that with the kind of security team.
Awesome. Fantastic. Well, Emmett, it has been a true pleasure. Thank you so much for sharing all of this wonderful wisdom with our audience and with the program. The chat has been great, folks. Thank you, those of you that are on the line, for staying so engaged for the great questions. I personally really appreciated a couple of pieces. Number one, your mentioning of so many of the soft skills that are critical in terms of the collaboration piece, even some of the technical writing components that we discussed here in the Q&A. These are all things that we're certainly kind of on the lookout for as we're approaching team composition and the selections that are made there. And then the other piece that I really appreciated is how you kind of broke down, a lot of the work in your field, and who's sort of responsible for what, and sort of the tasks that they likely see more days than not. So thank you, thank you, thank you. Truly, from the bottom of my heart, I say this every night during Cyber Rush Week. It's folks like yourselves who are willing to donate your time, volunteer your time to our program that allows us to do what we do and make an impact through providing resources and these kinds of learning engagements to our audience. So really appreciate your time tonight. Thank you for all of your hard work, with Red Trident, and protecting our critical infrastructure. Folks, we will be back here tomorrow night is the last night of Cyber Rush Week. Tonight we have a fireside chat between Casey Muratori with Molly Rocket Games and our co-captain from the Season 4 US Cyber Team, Josiah Stearns. They're going to be talk about all kinds of software engineering, architecture, low-level optimization, stuff like that. Should be really fun. So join us back here tomorrow, 8:30 p.m. Eastern time for our fireside chat. And let's give Emmett one more round of applause. Thank you, sir. Really appreciate your time. Have a